Okay, good morning, everyone. So we are about to start. So we are going to pick up from where we had left off last time on Wednesday. Okay, so um, so thank you, everyone who is here in the morning, and everyone who will watch the video later, sometimes in the afternoon, or tomorrow, or day after, or after that. Um, So we were looking at some of the solutions to improve the experience of users, the happiness factor of the content providers, and the stress on the networking resources. Okay, so we wanted to make sure that the user is able to make downloads faster, has high availability of the content available to that end user. So you want to make a request, you don't want to not be able to connect to the server. The server has to be available all the time. Okay, and similarly, the content provider would like to ensure that the content that they send to the end user, because often they make money out of that content. ESPN, Cricinfo, for example, or CNN.com, they make money out of the content that they serve to the end user. And they use a lot of advertisement techniques and marketing techniques to make money off the users. Um, so we wanted to make sure that everyone is happy, and in order to make the users happy, we wanted to first make sure that the user is able to download the content fast from the internet. You make a request, type the address in the web browser, in the browser address window. As soon as you type it, you want the page to be downloaded, to be appearing on your screen as soon as possible. Okay. um, so in order to make that time faster, we have to understand what are the processes happening behind the scenes. So first you have to establish a TCP connection. In order to have any HTTP request be sent, you first have to get the secretaries ready on each end. Remember, the TCP code is nowhere in the network. It is on the end systems. It is on the end systems. The secretary sitting at one end system, the other secretary sitting on the other end system. So these secretaries, they need to coordinate to make sure that the communication is established. A three-way handshake is established, and we say that a TCP connection is established before we can send any request, any HTTP request using that TCP connection. Once again, remember that HTTP is at the application layer, and TCP is at the transport layer. So HTTP uses the services of TCP. Any application layer protocol will use the services of either the TCP or the UDP. HTTP in this case requires reliable delivery, wants the every single bit in the HTML file to be replicated from the server to the client. So it needs reliable delivery and needs to use the TCP protocol. Okay. So how do you improve the performance of HTTP? We saw a few things. As HTTP evolved from one version to the next version, many things changed in HTTP. So for example, if you have to get many objects, each object over by sending one HTTP request, getting the object, sending another HTTP request and getting the object. So all of these HTTP requests in the primitive version of HTTP protocol, all of these HTTP requests, they would be sent on one single TCP connection. Once you send a request, and after that you will tear off the TCP connection and then establish a new TCP connection for sending a new request. So one of the improvement that we saw was that you bring persistence. You bring persistence. Okay, persistence means TCP connection is established just once. Send the HTTP request, get the response. Use the same TCP connection which is already established. Don't close that connection. Don't close that connection. Use the same TCP connection to send any further request to the HTTP server, as long as the requests for objects are for those objects which are hosted on the same server. Because TCP connection आप एक specific client और एक specific server के बीच में establish करते हैं. A specific machine talking to a specific server with both of them have unique IP addresses. Okay. If you have to get the object from some other HTTP server, from some other server with a different IP address, that's okay. Sometimes it happens. You know, in the HTML file, you have an image embedded, which is not hosted on that server, which is hosted on a third party server. So in that case, you will have to obviously establish a new TCP connection. But if you are getting objects from the same HTTP server, you can use a single TCP connection to get all the objects from that HTTP server. Okay, so that would be an improvement, because you are saving one round trip time. You are saving one round trip time, which is wasted in establishing the TCP connection, after which you can send the HTTP request. So you are saving on that one round trip time. So that's persistence. And then we also said that in addition to persistence, which is, by the way, standardized in HTTP 1.1, you can also use what we call pipelining. Pipelining means that even if you are using persistence with one single TCP connection, send HTTP request, get the response. Use the same TCP connection, send HTTP request, get the response. So one after the other, one after the other. So instead of doing this thing, request, response, instead of doing that, send all the requests that you have, for the HTTP objects that you want to get over HTTP simultaneously. Sub requests इकट्ठी भेजने, and possibly in one single TCP segment. Possibly in one single TCP segment or TCP packet, which, by the way, gets translated into IP packets. Okay. So you can send all of those HTTP requests simultaneously, and the objects will start coming to you one after the other, one after the other, one after the other. Okay, so you'll save a little bit of time. We had a picture last time drawn. I will not repeat that. So please make sure to watch that video from the previous lecture. So the other thing what you can do in improving the performance of HTTP fast user downloads is by opening up parallel TCP connections, not part of HTTP. Persistence and pipelining are part of HTTP, but opening up parallel TCP connections, sending HTTP requests simultaneously in parallel on those parallel TCP connections, that is something which is not part of HTTP. Each of those TCP connections that is opened up in parallel, you can send independent HTTP requests on those parallel TCP connections. Okay, so what parallel TCP connections would do is give you a higher, an unfair share of bandwidth available between you and the server. तो इतने सारे जो users जिनके साथ आप compete कर रहे हैं bandwidth लेने के लिए, you will be able to be unfair with those guys and establish multiple TCP connection, pretending that there are multiple users connecting to the same server, and you will get the bandwidth depending upon how many connections that you establish in parallel. Okay, and you can send the HTTP request simultaneously on parallel on those TCP connections. Of course, underneath there will still be physical layer limitation. If a link is operating at 10 megabits per second, you cannot send anything more than 10 megabits per second on that link. But remember, the TCP guy, the secretary guy, is also a regulator in the sense that it will divide the bandwidth. It's a guy who is somehow aware of all the traffic in the network, and it will equally divide the bandwidth among all the users using those network resources. Okay, so by opening up parallel TCP connection, you are cheating the TCP. You are cheating the underlying network, that you are more users. So the total bandwidth will still remain 10 megabits per second, 10 megabits per second, but now this 10 megabit per second resource will be divided among you and you and you and you if you have opened 4 TCP connections, and rest of the others. Okay. Um, so those are some of the improvements that we saw last time, that you can bring in HTTP or make parallel TCP connection. So some of those things to make the users download the files faster. Okay. The other things that you can do to make file downloads faster is you take the content, and instead of putting that content on a far off server, instead of putting the content on a far off server, put the content closer to the user who is requesting that content. Makes sense. If I have to bring something from a far off location, it will take long time. If I have to get something from local guys, locally, then it will likely be faster. It will perhaps be much faster. Okay. And that is something which we capture in caching and replication. The content comes closer to you. The content comes closer to you in caching and replication. These are two separate techniques, and the goal of both of these is to bring the content closer to the user. But which user? Which user we are talking about? So you have a server, maybe a central server, okay, and that server will get requests from all over the globe, and you want to take the content of this server and put it closer to the end user. Maybe you will keep the content on the server as well, of course, but you will cache it or replicate it or make a copy of it at some place closer to the end user. But which end user? Well, that answering that question will differentiate between caching and replication. Okay. So if a user at LUMS requests a content from a server hosted in the US. Okay. So the example is that your client is in LUMS, and the server from which it is requesting the content is hosted in the US. Okay. So that content will be brought back to LUMS. You send a HTTP request from LUMS campus to the server hosted in New York, and then you get the content. So once the content reaches the LUMS network and will be delivered to the end user, what LUMS network would do is they would also keep a copy of that on the router, which is on a device associated with the router, which is available with the IST department connecting the LUMS network to the outside network. And the reason for that would be that this request that I have sent from LUMS network to outside, the hope is that somebody else will send the request for the same content. The idea of caching, the locality of reference, which means you are sending requests for the same content over and over again from multiple users. Okay. बहुत सारे users same content के लिए popular content होगा, उसके लिए request भेज रहे होंगे. It is much nicer to cache that content. So when you send the request, a user originates the request, तो उसके नजदीक आके कहीं पे कैशिंग हो जाएगी. मे बी उसके अपने नेटवर्क के ऊपर, मे बी उसके ब्राउजर के ऊपर, मे बी उसके अपने नेटवर्क के ऊपर, मे बी the ISP, maybe the ISP which is providing services to LUMS, perhaps PTCL or PERN, there will be caching happening at those networks. But the caching will result once somebody sends a request first. पहली request भेज के content मंगवाना पड़ेगा, उसके बाद वो cache होगा. Okay. So the difference between caching and replication is this, that in the case of replication, nobody has to send the request for the पहले भी किसी को भेजने की जरूरत नहीं है. The server just anticipates. CNN just anticipates that there will be sufficient users. In Pakistan. Okay. So why not I put a server of CNN.com, a replica a replica of CNN.com somewhere hosted in Pakistan. Okay, somewhere hosted in Pakistan. Most of the bandwidth, that international network bandwidth that comes into Pakistan, is through Karachi, the optical fibers, undersea cables in Karachi. So CNN.com might say that let us host our content in Karachi, somewhere in Karachi, and then, as you might expect, they would not put the hardware there. They are not going to rent a space there. They're not going to put the hardware there. They will look for a company which provides this service, and we have companies for that. And those companies are called CDNs, or content distributions or content delivery networks. CDN, content distribution network, or content delivery network. Okay, so they will ask the content delivery network to please host the content for them. Why would the content delivery network do that? Because they are not only hosting the content for CNN, they are also hosting the content for Wall Street Journal, for eBay.com, for Amazon.com, for Macy's.com, for FedEx.com, for all the other websites. So lots and lots of customers for the CDN, and the CDN will make money because they have lots of customers. They will have lots of customers. So see, there is some benefit here. There is some benefit here if the CNN.com wanted to put up a server themselves, they would have to spend a lot of money for infrastructure, putting up a data center here, putting up servers here. They don't want to do that. They will just use a hosted scheme. So if you have a question, please go ahead and ask.
Yes, sir. I wanted to ask you, can other users use the same cache hosted on someone else's device? For example, someone else's browser.
Okay, so interesting question. So if there is a cache, which is hosted in PTCL's network, all the subscribers of PTCL network, they will be able to use that cache. Okay, that is one example. Let me give more example. If there is a cache which is hosted on LUMS network, only those people who are on LUMS network, they will be able to use that cache. Somebody outside the LUMS network will not be able to use that cache. So if there is some cache in your web browser, browsers also have caches, by the way. Okay? If there is a cache in your web browser, only you will be able to use that cache. Only you will be able to use that cache. Nobody else will be able to use that cache. Now, there are some modern techniques called collaborative caching, which is used in online social networks. They use this device to device caching and collaborative caching, using which you can use the cache on somebody else's device. But for that, some collaboration between these customers are needed, these end users are needed. Okay, in the traditional typical sense of caching and replication, if something is cached on your machine, it is yours only. If something is cached on your university network, it is for everyone who is using that university network. If something is cached on the ISP that you are using, this cache can be utilized by anyone who is being serviced by that single ISP. Does that answer your question, Suhaib?
Yes, sir. Thank you.
Okay, great. So anyone else who has a question about caching? Okay, by the way, we have a few questions in the homework. There is a homework which is out, and there are some questions on the performance of HTTP. If you do persistence, pipelining, parallel TCP connection, how much benefit can you get? So please take a look at those questions. Very, very simple questions, just, basic analytics is used. Drawing the timing diagram, those vertical lines, remember, between client and server that we used to draw, drawing that would be very useful for solving those questions. We also have some questions on caching. What is the benefit of caching? So one benefit that we see is that, somebody requested a content, they got that content, and that content got hosted in their university network. Anyone else who sends a request in future for the same content will get the content from the university network, will save a lot of time. You don't need to go to all the way to some server hosted in New York if the content is hosted on LUMS campus. Okay, so that's a big advantage. How much time can you save? Well, you save some time. you save some time, and you have to calculate that time in the problems in the homework. Once again, simple problems. Just think about the problems and focus on what data is given to you, what we are trying to uh, optimize, what kind of time we are talking about. So please take a look at those questions. um, we, by the way, we have a test on Sunday as well, and the topics that we are covering today and yesterday and the lecture before, more recent lectures sort of, uh, we will be asking questions about that content. So you have another question?
Yes, sir. It's regarding caching, sir. So for example, if cache is hosted at LUM server, so when
Mhm.
servers will allow the data to cache, or any data can be cached.
So servers can allow that data. Servers can also forbid that data. मना भी कर सकते हैं और allow भी कर सकते हैं. We will talk about that in a minute, in a couple of slides. Okay. So why does caching work? The caching works because of the locality of reference, because you have repeat requests for the same content coming in future. Okay. If one content is never repeated, is the request for that content is never repeated, caching that content is not going to be useful. Is not going to be useful. This makes sense. This is similar to the caching that you see in the processors, who access the memory area, and bring something into the maybe L1 cache or L2 cache or L3 cache, or maybe even in the registers, hoping that this area of memory, or the variable stored in there, or the data stored in there, will be referenced in future sometime soon. So the CPU will save a lot of time. Instead of bringing the data from a memory which is on a separate chip, उससे लेकर आएंगे तो बहुत टाइम लग जाएगा. ठीक है. How about say just bringing it in advance? So if anyone has taken the computer architecture course, you guys might have looked at branch prediction techniques, in which you predict where the code is going, what kind of variables it will need, where they are stored. So you look ahead in the program and bring that memory ahead of time, and cache it in the processor. The kind of caching we are talking about is similar but not the same. Obviously, we are talking about the caching of web content. We are talking about the caching of HTML files, of images, of videos. Okay, so we're talking about the caching of that. Okay. By the way, I use the term caching, but as you may have noticed, that caching and replications, although two different concepts. In replication, nobody has to send the first request. It's the server who will decide that, oh, this is a popular area. CNN will say it's a popular area. Anything that we publish, that we produce, we just will host in Karachi. So replication is sort of a push model, and caching is a pull model. Somebody pulls the content first, and then it gets cached. Okay. In replication, the server will just push the content. Okay, without anyone pulling. Future में कोई pull कर लेगा, that's okay, but that's the difference between caching and replication. But when we use the term caching, generally we cover both of these. थोड़ी generic term हो गई है ये caching. It will include caching as well as replication. So why does this work? This works because of the locality of reference, which means multiple requests for the same object, same content. And how well does the caching work? Well, it does work very well. If you have too many requests coming in for a content, all of those requests will be served locally. If there is a large overlap in the content, that will be very, very useful. So for example, even if you have multiple web pages, by the way, and they use the same image, it is best to just cache that image, because even though the two web pages are different, they are using the same image. So that means if the image is cached, then the second web page, when will be requested, this image will be embedded in that. And since we launch a new HTTP request for the embedded content, so the content will already be cached, the object, the image will already be cached. Okay. Although कि वो web page एक दूसरे की request गई है, लेकिन चूंकि उस web page के अंदर, दूसरे web page के अंदर वही same content था, same image embed हुआ था जो पहले वाले page के अंदर था, तो इसका मतलब है कि we can get that content, that image locally from a local cache. No, by the way, when I use the word local, that really means somewhere closer to the end user. So so if end user is in LUMS and the server is in New York, you know, anything in between New York and LUMS campus, you know, is in between the user. It's closer to the user compared to New York. You know, so even if you cache something in Karachi, that's still closer to LUMS as compared to New York. Okay, if you cache something in the network of Singapore Telecom, that's still closer to LUMS as compared to New York. So you have this choice of caching at various different levels. बहुत सारी जगह पे anywhere between your browser and the server कहीं पे भी कैश कर सकते हैं. बाज़ दफा सर्वर अपने पास ही कैश लगा देते हैं, अपने पास ही कैश लगा देते हैं. We'll talk about that in a minute. Okay? उसके लिए थोड़ा सा वेट करें. So example, what are the benefits for LUMS? LUMS का benefit क्या होता है इससे कैशिंग करने से? The benefit lies because you have reduced access link bandwidth. What is this access link thing? The access link is the link which provides access to a university network or an enterprise network or a home network. That is called an access link. The link which is coming into your house is the access link. Using that link, you access the internet. So LUMS has an access link which connects LUMS router to the PTCL network or HEC network or Wire Tribes network. So that access link using which my network accesses the rest of the internet, that access link has a certain bandwidth. And generally that bandwidth is very limited. Within LUMS network, we have 10 gigabit per second. 10 gigabit per second is prevalent on campus. Okay? You don't have the luxury of having 10 gigabit per second access link. The access link bandwidth is much smaller. Why? Because it is very expensive. In LUMS, I can put wires which run 10 gigabit per second, which run 1 gigabit per second. Okay? But outside LUMS network, I have to pay someone to put those wires. Okay, not just the price of the wires. Price of the wires तो हमें तब भी पे करनी पड़ेगी जब LUMS के अंदर डाल रहे हैं. But the price of the wire, in addition to the service provided by the service provider, they will charge heftily for that. Okay, so the access link bandwidth is always choking. So the benefit for LUMS of caching is that there will be reduced access link bandwidth, which is typically more expensive than a cache. Cache से ज़्यादा expensive होती है access link bandwidth. Okay, so based on some analysis, you will decide whether you want to put a cache or you don't want to push a cache. Cache की अगर price बहुत ज़्यादा हो गई है, आप उतने पैसे ही नहीं बचा रहे access link bandwidth में, तो फिर शायद cache डालने की ज़रूरत नहीं है. There may be one other reason that you will still want to put a cache. वो क्या reason हो सकती है? Anyone? Please raise your hand if you can answer this question. हम ये कह रहे हैं कि access link bandwidth LUMS की बचेगी अगर आप cache लगा दें, ठीक है? लेकिन access link bandwidth जो बचेगी, थोड़ा पैसा बचेगा LUMS का, okay? लेकिन cache डालने में कुछ पैसा खर्च होगा, okay? So if you spend more money in putting the cache in here, obviously it will not make sense for LUMS to put the cache in here if the cost of putting the cache is more than the saving that you will do in your access link bandwidth bill. उस बिल में जितनी कमी हो रही है उससे ज़्यादा की तो कैश आ गई है, फिर LUMS जो है वो उसको कोई इंसेंटिव नहीं है कैश लगाने का. There might still be one other reason you would want to put a cache on LUMS network. What is that reason? Anyone? Any takers? कोई तुक्का ही लगा दें. जी Suhaib, thank you for raising the hand.
So maybe if more users are requesting that cache or something, ज़्यादा demand होगा.
नहीं, वो तो ठीक है, वो तो डिमांड ज्यादा होगा तो हमारी एक्सेस लिंक बैंडविड्थ बचेगी ना. अगर ज्यादा डिमांड हो रही है तभी तो एक्सेस लिंक बैंडविड्थ बच रही है. वो तो हमने बचा ली, लेकिन उससे जितने पैसे बचाए उससे ज्यादा पैसे की कैश लग गई है या उससे तकरीबन उतने पैसे की कैश लग गई है, तो फिर क्या फायदा हुआ कैश लगाने का. कोई और?
सर फास्ट रिजल्ट।
हाँ भाई, यूजर भी तो खुश हो गए हैं। जिसने जाके न्यूयॉर्क से कंटेंट लेकर आना था वो अब लम्स कैंपस से ही कंटेंट ले रहा है, उसका तो राउंड ट्रिप टाइम कितना बच गया है। हैप्पी कस्टमर्स, हैप्पी कस्टमर्स, और हैप्पी कस्टमर्स होंगे तो वो ज्यादा पे कर देंगे, आपकी फीस भी बढ़ा देंगे। लम्स वाले तो आप कुछ नहीं कहेंगे उनको। सो फीस के ऊपर और डिस्कशन नहीं होगी, बहुत हो चुकी है पहले। ओके, सो नाउ हाउ डू यू गेट द कैशिंग इम्प्लीमेंटेड? कैशिंग करते कैसे? कैशिंग करने के लिए आपको there are a few modifiers, a few header lines that you add in the HTTP request as well as in the HTTP response. Remember हमने क्या कहा था? HTTP get request, एक get request line होती है, उसके नीचे कुछ request header होती हैं जो बताते हैं रिक्वेस्ट के अंदर क्या बताते हैं, आपका यूजर एजेंट कौन सा है, कंटेंट आपको किस लैंग्वेज के अंदर चाहिए, एंड सो ऑन एंड सो फोर्थ, मोर इन्फॉर्मेशन। सिमिलरली जहाँ जो रिस्पॉन्स आता है उसके अंदर वो बताता है कि कंटेंट का साइज कितना है, कितनी बाइट्स हैं इसके अंदर, कौन सी लैंग्वेज वाला कंटेंट आपको आपके पास आ रहा है, एंड थिंग्स लाइक दैट। नाउ those HTTP headers in the request and response, there can be multiple HTTP request headers, okay, request and response headers, okay. So we have these additional request response headers within HTTP which help in caching, okay. So what are those? Modifier in the get request, जो HTTP get request हम भेजते थे ना, request भेजी get request, उसके साथ आपने बता दिया ये वाला रिसोर्स चाहिए, रिसोर्स आपको आया, तो in that request, let's say your browser has a cache, your browser has a cache, आपके ब्राउजर ने जो है वो कैश किया हुआ है आपकी पुरानी किसी एक फाइल को। लेट्स से यू वेंट टू www.dawn.com और उस पर कोई आर्टिकल आया था और वो आर्टिकल आपने जो है वो व्यू किया था अपने ब्राउजर में। योर ब्राउजर हैज कैश्ड दैट, योर ब्राउजर हैज कैश्ड दैट फॉर यू, ठीक है। कोई नेटवर्क की कैशिंग की बात नहीं कर रहे हैं, कोई लम्स कैंपस की कैशिंग की बात नहीं कर रहे हैं, आपके ब्राउजर ने कैश कर लिया उसको। ब्राउजर्स आल्सो डू कैशिंग, ओके। द नेक्स्ट टाइम यू टाइप द एड्रेस फॉर दैट आर्टिकल, दोबारा से वो आर्टिकल पे जाने की कोशिश करेंगे तो क्या होगा कि आपका ब्राउजर कोशिश करेगा मैं लोकली इसको सर्व कर दूं, और आपको इमीडिएटली नजर आ जाएगा, इमीडिएटली, ओके, वेरी नाइस। But it would be very bad if that article has changed. Maybe it was the daily update news, it changes every day. You don't want stale news coming to you. So what would happen is you will still send a get request. You will still send a get request. Your browser will still send a get request to the server and will say if modified since, ये एक रिक्वेस्ट हेडर होगा और आगे उसके एक डेट बता देंगे कि यार मेरे पास इस डेट का कंटेंट पड़ा हुआ है जो मैंने कभी पहले तुमसे मंगवाया था। if your content, if the file you have is modified since this date, then please send it to me. If it is not modified, then thank you very much, don't need to send it to me, ठीक है। लेकिन मुझे बता तो दो, मुझे बता दो कि मॉडिफाई हुआ है या नहीं। So the client will send the request, with if modified since, and the server will return not modified if the resource has not been modified on the server since the time which has been specified, okay। Now आप सोचते होंगे कि यार ये बड़े अजीब लोग हैं कि यहाँ आपने कैश में कंटेंट वहीं से सर्व करना है, सर्वर से जब रिक्वेस्ट कर ही ली है, सर्वर तक आप पहुंच ही गए हैं, उससे आपने पूछ ही लिया है कि अगर मॉडिफाई हो गया है तो मुझ तक भेज दो, सर्वर आपको जवाब भी दे दिया है सर्वर ने कि नॉट मॉडिफाइड है, तो राउंड ट्रिप टाइम तो आपने कंज्यूम कर ही दिया, राउंड ट्रिप टाइम तो कंज्यूम हो गया सर्वर से ये पूछते पूछते। तो फायदा किस चीज का हुआ? तो फायदा किस चीज का हुआ बताते हैं अभी क्या फायदा हुआ। सो फॉर एग्जांपल ये गेट रिक्वेस्ट है जो मेरे ब्राउजर से सर्वर को जा रही है। मेरे ब्राउजर ने पहले कभी सर्वर पे रिक्वेस्ट भेज के, ये एक HTML फाइल थी quiz2.html, we don't have quizzes in the class, we do have tests and we have one on Sunday by the way. So quiz2.html ये एक फाइल मंगवा ली है इसने सर्वर से ना, ठीक है। वो किसी होस्ट पे जगह पे होस्ट हुई थी, यूजर एजेंट भी उसने बता दिया था। ये रेड वाला है, अगर आप हेडर इस पे गौर करें, इस पे लिखा हुआ है कि इफ मॉडिफाइड सिंस, और इसने ये कोई पुरानी डेट डाल दी है, ये पुरानी डेट डाल दी है जब उसने पहले ये फाइल मंगवाई थी. सो दिस ओल्ड डेट is the date and time when previously this web browser has gotten the content from the same server and has cached it. अब उसके पास कैश में पड़ा हुआ है, इसलिए उसने सर्वर को ये रिक्वेस्ट भेज दी है कि अगर मॉडिफाई हुआ है तो प्लीज मुझे भेज दो, अगर नहीं मॉडिफाई हुआ तो बता दो कि मॉडिफाई नहीं हुआ. ठीक है. So the client will specify the if modified since time in the request and the server will compare this against the last modified time. जो उसके पास लास्ट मॉडिफाइड, हर सर्वर के पास स्टोर्ड होती है फाइल, उसको पता होता है लास्ट मॉडिफाइड कब हुई है. लास्ट मॉडिफाइड टाइम के साथ जो है वो कंपेयर करेगा. एंड इफ नो चेंज हैज अकर्ड सिंस द टाइम मॉडिफाइड, जो क्लाइंट ने उसको भेजा था, तो वो नॉट मॉडिफाइड का रिस्पॉन्स भेज देगा. फिर ओके 200 नहीं आएगा आपको. Normally, though, when you send an HTTP request, you will get the content and OK 200 response. या अगर content नहीं मिलता तो 404 आ जाएगा. यहाँ पे वो आपको 300 या इस टाइप का कुछ होएगा. Okay, I forgot the code for that, but वो not modified का कुछ और code number होता है, ना 200 होता है ना 404 होता है. Okay, 200 means it's okay, I'm sending you the content. 404 का मतलब the content doesn't exist. एंड दिस वन इज, ये सारे HTTP के कोड्स जो हैं वो उसके RFC के अंदर लिस्ट हुए हैं. ठीक है. तो या तो वो नॉट मॉडिफाइड भेज देगा या वो ओके करेगा, और अगर फाइल चेंज हुई है, अगर फाइल चेंज हो गई है तो वो ओके करेगा और नई फाइल भेज देगा, लेटेस्ट वर्जन भेज देगा फाइल के साथ. ठीक है. तो जब सर्वर से जाके पूछ ही लिया है, जब राउंड ट्रिप टाइम कंज्यूम कर ही लिया है, तो भाई फाइल ही मंगवा लेते, तो फाइल ही मंगवा लेते. व्हाई द एफर्ट, व्हाई द एफर्ट? Anyone who can answer? जी सुहेब.
सर हमारी अगर फाइल पुरानी है तो जो फाइल ट्रांसफर होने का टाइम है वो बच जाएगा.
फाइल ट्रांसफर होने का टाइम बच जाएगा. रिक्वेस्ट तो चली गई है, लेकिन रिक्वेस्ट जो है बहुत छोटी सी होती है, और फाइल अगर बड़ी है वो सारा टाइम ट्रांसफर होने का जो है ना वो बच जाएगा, तो टाइम बच जाएगा. सिंपल, आसान सी चीज है. ठीक है. So if modified since is included in the request header, रिस्पॉन्स के अंदर क्या होगा? रिस्पॉन्स के अंदर और एडिशनल इंफॉर्मेशन भी आती है. बाय द वे, रिस्पॉन्स हेडर के अंदर भी कुछ इंफॉर्मेशन आती है. एक ये आ सकती है एक्सपायर्स, और साथ आगे टाइम लिखा हुआ होगा. एक्सपायर्स एंड एन एसोसिएटेड टाइम, दैट मींस हाउ लॉन्ग इट्स सेफ टू कैश द रिसोर्स. तो सर्वर ने पहले ही बता दिया. सो फॉर एग्जांपल, इफ cnn.com it updates the news item, news front page, hot news front page, वो एवरी आवर पे चेंज करता है. तो जब भी रिक्वेस्ट गई है तो उसको पता है अब अगले 1 घंटे में चेंज होने वाली नहीं है, तो वो 1 घंटे बाद का ये जो भी टाइम होगा जब भी चेंज होनी होगी उस वक्त का टाइम दे देगा. वो कहेगा कि यार उससे पहले पहले जो है ना, उससे पहले पहले मुझे रिक्वेस्ट भेजने की भी जरूरत नहीं है, इट विल एक्सपायर व्हेन इट एक्सपायर्स. सो आप ये इफ मॉडिफाइड सिंस को भी बचा लेंगे, इसको भी बचा सकते हैं अगर सर्वर ने कभी आपको एक्सपायर्स का बता दिया कि इट विल एक्सपायर समटाइम्स इन फ्यूचर. तो 3-4 दिन तक इसने एक्सपायर नहीं होना. 3-4 दिन तक अगर तुमने दोबारा रिक्वेस्ट भेजनी है, so just use your own copy because I'm not going to change it for some time. ठीक है. So that's how you save on sending that for small request भी भेजने की जरूरत नहीं है. Of course अगर भेज देंगे तो वो आपको ये कहेगा कि भाई मॉडिफाई नहीं हुआ है. Sometimes server might also say no cache if the content is changing very quickly. News updates बहुत तेजी से आती हैं. So the server might use this response header. Very important to realize कि ये if modified since ये request header में जाएगा और expires and no cache ये response header में आएगा. Which means कि ये caches के लिए all the caches on the way. By the way, there will be multiple caches on the way. All the caches on the way, उनके लिए ये एक notification आया है. उनके लिए एक notification आया है कि please इसको cache ना करें. This is dangerous to cache this content because it is dynamically changing. It's changing very, very quickly. So do not cache it, please. Okay. So server can certainly do that. Now, caching up कहाँ करनी है हमने? We have talked about कि there is a entire world between the client and the server. NUMS campus and somewhere in Europe or New York or San Francisco. This is entire global network in between the client and server. So where do you cache the content? So जैसे हमने बताया, you can cache very close to the server, you can cache very close to the client, and you can cache somewhere in between. You can cache somewhere in between. Okay. So where do you do the caching? There are multiple options. You do the caching at the client. You can do the caching at the server. You can do caching at what we call forward proxies. अभी बताते हैं क्या चीज होती हैं. You can do caching at reverse proxies. Forward proxies are the places which are closer to the end user. So for example, on LUMS network, if I put a proxy, that will likely be a forward proxy for all the users. If PTCL puts a proxy, that will also be a forward proxy. The reverse proxy will be placed by the CNN server. This is closer to the server. And then you also have content distribution networks, in a network, a shared network in Karachi, big facility, lots and lots of servers. They will host content for many different organizations, Okay. So where do you do the caching? Extending on that, the baseline is that many clients will access the same information. Benefit होना चाहिए इस baseline के ऊपर. Okay. So you want to avoid unnecessary server load and unnecessary network load. So खामखा का network का load भी नहीं लेके जाना, खामखा server को भी overwhelm नहीं करना. So if too many clients are requesting the server, then the server might get overwhelmed. Okay. So एक possibility जो server वो ये कर सकता है कि अपने पास जो है वो proxies या caches लगा ले. So one possibility is the server uses what we call these reverse proxies. These are the servers. These are the servers which are friends of this main server, and act as reverse proxies in the sense that they will avoid too much load on this single server. So maybe you will just load balance among these guys. Perhaps these reverse proxies are hosted in the same data center where this server is located. ये भी न्यूयॉर्क में कहीं डेटा सेंटर के अंदर पड़ा हुआ है और ये सारी रिवर्स प्रॉक्सीज ये भी कहीं उसी डेटा सेंटर के अंदर होस्ट हुई है. All they are doing is they are just dividing or distributing the load on this single server onto these multiple machines. So they will decrease the server load. If you bring a cache closer to the server, this will decrease the server load. Think about it. You are not doing any favor with the network load नहीं कम हो रहा है. नेटवर्क अभी भी जो रिक्वेस्ट है वो सारी रिवर्स प्रॉक्सीज तक जाएंगी. ठीक है. So if reverse proxies and the server, they are all hosted in the same data center in New York. So LUMS से जितनी रिक्वेस्ट CNN.com के लिए जा रही हैं वो सब उस न्यूयॉर्क डेटा सेंटर के अंदर जाएंगी. नेटवर्क के ऊपर कोई बचत नहीं होगी. LUMS की नेटवर्क से बैंडविड्थ निकल रही है. Okay? So reverse proxies alone will not alleviate the network issues. They will alleviate the load issues on the server. लेकिन network issues को जो है वो address नहीं करेंगे. So this is typically done. The reverse proxies are typically done by the guy who is providing the content. CNN.com वाले करेंगे अपने server को बचाने के लिए. ठीक, उस पे heavy load को बचाने के लिए. Then you also have what we call forward proxies, which are closer to the clients. वो कहाँ पे हो सकती हैं? वो ISP, उस ISP में हो सकती हैं, which is providing the services to these clients. These proxies can also be on a enterprise network or a campus network, just as LUMS. LUMS के ऊपर अगर हमने कोई proxy लगा दी तो हम उसको forward proxy कहेंगे. This is by the way a terminology which is used. Caches are doing exactly the same thing. Reverse proxies, forward proxies, they are doing the same thing. कि repeat transmission of the same content उसको बस बचा रहे हैं. ठीक है. So these will be done typically by ISPs or enterprises or universities. Okay, makes sense? Okay, now you can also do caching somewhere in between. Okay, you can also do caching somewhere in between. Normally we do not do that. Normally we do not do that. So what do we do somewhere in between? Somewhere in between, we don't do caching, we do replication. We do replication. So what we do is that we put a CDN network somewhere here. कोई CDN यहाँ दरम्यान में लगा देते हैं, content distribution network or content delivery network, and then we replicate the server content. We replicate the server content onto that CDN. उस CDN के ऊपर हम replicate कर देते हैं. So how does replication work? So replication में you replicate the popular website across many machines distributed along the globe, around the globe. So one famous content distribution network is Akamai. Akamai. शायद आप में से कुछ लोगों ने नाम सुना हो, या मे भी सबने सुना हो, या मे भी किसी ने भी ना सुना हो, but now you have heard. Akamai is a company which has servers across the globe, tens of thousands of locations. Okay? So website जो है वो decide करेगी, Akamai से कहेगी कि यार अपनी फलानी लोकेशन के ऊपर जाके हमारे कंटेंट को replicate कर. So will be copy of that content replicated on those machines. The request instead of going to the servers will actually go to the CDN, content distribution network को जाएंगी. ठीक है, मैंने भेजी रिक्वेस्ट www.cnn.com, चली गई वो akamai.com के पास. So ये कुछ translation कैसे होगी? Well, this translation is pretty easy. It's pretty easy. You have to do some processing of the content. कुछ थोड़ी सी processing करनी पड़ती है, but it's typically done, fairly easily. Okay. So what does this CDN do? CDN spreads the load on the server. Obviously, ये load भी distribute कर देता है across different servers. Okay. And this also places the content closer to the client. So remember, हमने forward and reverse proxies की बात की थी. If the proxy is closer to the server, so वो network के लिए useful नहीं है, वो server के लिए useful है. If the proxy is closer to the end user, तो वो सर्वर के लिए यूजफुल नहीं है, उस पे लोड उतना ही होगा, वो एंड यूजर के लिए यूजफुल है. ठीक है, CDN is somewhere in between. And CDN is useful for the server, उसके लोड को जो है वो रिड्यूस करेगा, and also for the client, उसके रिस्पांस टाइम को वो रिड्यूस करेगा. Okay, so this will help when the content is not cacheable. This will also help even when the content is not cacheable. When the content is not cacheable, what do we mean by that? That means that there is some content which is generated dynamically. You don't have those HTML files sitting in the file system. पहले से file system के अंदर HTML files नहीं पड़ी हुई हैं. These are dynamic pages which are generated on the fly. हमने इसकी एक example दी थी कि किसी word का अगर आप meaning जानना चाहते हैं, एक डिक्शनरी की सर्विस है, तो they don't have an HTML for that. हर एक के लिए HTML नहीं रखी हुई है, तो बस डिक्शनरी से वर्ड का मीनिंग उठा के लेकर आते हैं जो एक डेटाबेस में कहीं पड़ा हुआ है, और एक स्टैंडर्ड टेम्पलेटेड HTML फाइल है उसके बीच में लिखते हैं. सो दैट मींस ए न्यू डायनामिकली जनरेटेड HTML फाइल फॉर एवरी रिक्वेस्ट. सो इफ द कंटेंट इज नॉट कैशेबल, इफ यू हैव डायनामिक पेजेस, देन यू कैन स्टिल होस्ट दोस ऑन CDN. प्रॉक्सीज के ऊपर वो आप नहीं कर सकते. प्रॉक्सीज के ऊपर सिर्फ आप ऑब्जेक्ट्स ही सेव करेंगे, which could be an HTML file, which could be an object. Okay, डायनामिक HTML फाइल को सेव करने का कोई फायदा नहीं है, बिकॉज मैंने एक वर्ड का मीनिंग पूछा, वेरी अनलाइकली somebody else will ask the meaning for the same word. मैंने अपनी शॉपिंग कार्ट के अंदर कुछ आइटम्स डाली हैं, वेरी अनलाइकली somebody will have exactly the same items in their shopping cart. Okay. So the problem is which client to be directed to which replica. If you replicate the content from the server onto these many CDN nodes, Akamai को कहा ये आप जो है ये सब कॉन्टिनेंट्स के अंदर जाके ये रेप्लिकेट कर दें. सो कौन सा क्लाइंट किसके पास जाएगा? What makes sense is that people sitting in Asia should go to a CDN server which is hosting that content, replicating that content, and is sitting in Asia. उसको यूरोप में जाने की जरूरत नहीं है. Customers who are in, or end users who are in Europe, they should reach an Akamai server which is closer to them in Europe. Okay, so you should pair the clients. With nearby servers. Why is that? अगर nearby पे नहीं भी करेंगे ना, तो सर्वर का लोड तो आपने बचा लिया, CNN.com का लोड तो आपने बचा लिया है, लेकिन क्लाइंट्स के साथ जाती कर दी अगर उनको नजदीक वालों के पास नहीं भेज रहे हैं। ए समबडी सिटिंग इन यूरोप, आप उसको जो है वो जापान में उठा के भेज दें, वहां से सर्विस दे रहे हैं। नहीं, if there is a replica available in Europe, serve the clients who are in Europe from that particular replica, उसी replica से जो है उसको सर्विस दे। Okay, so why is that? Because there are two benefits of this. One benefit is load balancing across the replica and also lower latency for the end users. एक तो एंड यूजर्स को लोअर लेटेंसी मिलेगी, जो यूरोप में बैठा है उसको यूरोप से कंटेंट मिल जाएगा, जो नॉर्थ अमेरिका में है उसको नॉर्थ अमेरिका से मिलेगा, जो साउथ ईस्ट एशिया में उसको साउथ ईस्ट एशिया से कंटेंट मिल जाएगा। एंड द अदर थिंग व्हिच विल हैपन इज कि वो लोड बैलेंसिंग भी ऑटोमेटिक हो जाएगी, बिकॉज यू एक्सपेक्ट द लोड टू बी जनरेटेड फ्रॉम एवरीवेयर अक्रॉस द ग्लोब, सो एक नेचुरल लोड बैलेंसिंग will happen. So how do you implement this? The request which is generated from Lahore is served by a server sitting in Pakistan or Southeast Asia. A request which is generated in Denmark is served by a server, by a replica of the server, by a CDN node which is hosted in Germany. ठीक है, कैसे ये इम्प्लीमेंट करेंगे? इसको इम्प्लीमेंट करने के लिए बड़ा आसान सा जो सोल्यूशन एक यूज किया जाता है वो ये कि the DNS will return the addresses based on the client's geolocation. Remember DNS क्या चीज थी? DNS ये चीज थी कि www.cnn.com को वो एक IP एड्रेस में ट्रांसलेट करता था, एक IP एड्रेस में ट्रांसलेट करता था, and everyone will go to that IP address in the globe. ठीक है, अगर हम ऐसा कर दें कि यहाँ वाला DNS, if I run the DNS from Pakistan, तो www.cnn.com के लिए वो मुझे कराची की रेप्लिका का एड्रेस दे दे। And if I run the DNS, I want the translation from www.cnn.com sitting in Europe, तो वो मुझे यूरोप में जो रेप्लिका सर्वर है उसका एड्रेस दे दे, तो the job is done. And you can do that in DNS. DNS allows you to do that. We have not studied DNS as yet, but DNS allows you to do that. Okay, so this is very interesting. I can probably show you how DNS will be working, maybe in a little bit. So caching and replication is generally provided as a service by content distribution network. CDN जो है वो replication कर रहे होते हैं। यहाँ पे caching का word जो इस्तेमाल किया गया है, this is simply in the sense that you are making a replica of the content. So this kind of caching is really replication. Okay? So large scale distributed storage infrastructure usually administered by one entity, and Akamai is the biggest example of that. So this, by the way, this is a little bit old information. So 20,000 plus locations के ऊपर इन्होंने अपने server रखे हैं, and they will provide caching and replication service. So mostly a combination of pull when you send a request and then the content will be cached. Okay, पहले यूजर ने रिक्वेस्ट किया और फिर वो कैश हो गया और बाकी subsequent users का फायदा हो गया. It could also be a push replication, mostly push replication. A push replication में ये है कि अभी किसी ने रिक्वेस्ट नहीं किया, लेकिन we anticipate that lots of people will request it, so हम उसको पहले ही push करके सर्वर्स के ऊपर रेप्लिकेट कर देते हैं, CDN सर्वर्स के ऊपर. So expectation of high access rate. While we do that, we can also do some processing. So for example, we can handle some dynamic web pages there. We can do some transcoding, images appearing on desktop machine and a mobile phone, size of those images may be reduced and things like that. Kuch transcoding is tarah ki kar sakte hain. So an example of the CDN is Akamai. So Akamai will create the new domain names for each client. जो भी उनका client होगा, CNN.com, WallStreetJournal.com, Walmart.com, Target.com, all of these will be customers of Akamai. Akamai से कहेंगे भाई हमारा content लेके इसको replicate कर दो अपने जो 20,000 से ज़्यादा locations हैं उनमें से ये 4, 6, 5, 10, 100 जितनी भी जगह हैं वहाँ पे host कर दो इसको. Okay, so what Akamai will do is उसने make sure करना है कि जो clients जो request भेजें वो बजाय CNN पे जाने के वो Akamai के सर्वर्स पे आ गए. So for example, they will have this a128.g.akamai.10 for cnn.com. cnn.com के लिए ये होगा. और CDNs के जो DNS सर्वर हैं, they are authoritative. We don't know about the authoritative DNS servers. We will find out about them. But authoritative DNS servers वो होते हैं जो translation कर सकते हैं कि cnn.com is translated into this IP address. These are the DNS servers which are called authoritative. Okay. Other DNS servers which are not authoritative, they don't know the answer, but they can get the answer for you. वो translation आपके लिए फिर भी लेकर आ सकते हैं DNS servers. Okay. So the client content, CNN का जो content होगा, हम उसको Akamize कर देंगे. You know, this is the terminology very commonly used. So for example, if you have a URL which is http://www.cnn.com imageoftheday.gif. Okay. जब इसको Akamize करेंगे तो ये क्या होगा, ये चेंज हो जाएगा a128.g.c. अब akamai.net सर्वर का नाम ही चेंज हो गया है एंड imageoftheday.gif इसमें चेंज हो गया है. इसको हमने Akamai के सर्वर्स पे होस्ट कर दिया होगा. When I send the request will go to this server जो ये रेप्लिका है उसके पास जाएगी. Now पता कैसे चलेगा कि मैंने इसके पास रिक्वेस्ट भेजनी है? वो होगा ये कि जो बेस HTML फाइल जिसके अंदर ये इमेज रेफर हुआ होगा, वो बेस HTML फाइल CNN अपने पास होस्ट करेगा. लेकिन CNN अपने पास होस्ट करके जितनी बेस HTML फाइल हैं उसके अंदर जो एम्बेडेड URLs हैं उनको रीराइट कर देगा. उनको रीराइट करने का ये मतलब है कि जहां cnn.com/imageoftheday.gif लिखा हुआ था उसकी जगह a128akamai.net imageoftheday.gif लिख देगा. इसका मतलब है कि पहली रिक्वेस्ट, the first request will go from my browser to the actual CNN server. HTML बेस HTML वहीं से उठ के आएगी. जो बेस HTML जब मेरे पास आ गई उसके अंदर 500 इमेजेस थे. 500 इमेजेस जो थे उनके जो लिंक्स थे वो सारे Akamai के लिंक्स थे. I will get all of those images from Akamai. This is called Akamizing the content. वो जो HTML फाइल थी उसको आपने Akamize कर दिया. जहां पे रेफरेंस CNN का होना चाहिए था, CNN के बजाय अब वो Akamai का रेफरेंस आ गया. ठीक. So this is great. So request will now be sent to the CDN infrastructure. Akamai को जाएंगी instead of CNN server. So the content delivery becomes cost effective by doing so. There are other ways that it becomes cost effective. The general theme is you have multiple sites hosted on shared physical infrastructure. जो Akamai करता है वो अपने पास multiple sites को जो है host भी कर सकता है. आपने देखा होगा कि if you get a domain name from domain name provider such as godaddy.com, उससे जाके आप domain name ले लेते हैं. आपने कोई business शुरू किया है, domain name लेते हैं, वो आपको space भी provide कर देते हैं. That's a shared physical infrastructure, shared space, and this rides on the benefits of the efficiency of statistical multiplexing. So this is not that same statistical multiplexing जो हमने packets के लिए देख ली. This statistical multiplexing means कि बहुत सारी websites एक ही infrastructure पे host हुई हैं in the hope कि सबके पास simultaneously बहुत ज़्यादा traffic नहीं आएगी. तो वो एक statistical multiplexing आप उनके बीच में कर रहे हैं. Also it explores the economies of scale. यानी अगर CNN.com ने अपना रेप्लिकेशन करनी थी तो या तो वो अपनी जगह रेंट करते, सर्वर अपने खरीद के लगाते, बिजली का इंतजाम करते, सारा कुछ. इकोनॉमीज ऑफ स्केल का मतलब ये है कि उन्होंने Akamai से कॉन्ट्रैक्ट कर लिया कि हम आपको इतने थोड़े से पैसे देंगे. बट Akamai can still make money because they have 20,000 customers, 50,000 customers, 100,000 customers. वो सारे कस्टमर जो हैं वो Akamai को पैसे दे रहे हैं, तो इकोनॉमी ऑफ स्केल वहां से आएगी. And you will also amortize the human operator को. एक ही human operator होगा जो बहुत सारी servers को handle कर रहे हैं. So examples would be web hosting companies such as GoDaddy.com, CDNs, also the cloud infrastructure, Google Cloud, Microsoft Azure, Amazon Web Services or Amazon Computing Services. These are all examples of statistical multiplexing. You have shared infrastructure which exploits the economies of scale. Okay, right. So we talk about DNS. By the way, we did promise that we will show you something. So यहाँ पे हमने ये कहा था कि the job of the DNS that we are going to study now, the job of the DNS is to return different addresses based on the client geolocation, Okay, so I'm going to show you a program. I'm going to show you a program which is called NSLOOKUP. NSLOOKUP जो है वो क्या करता है? वो simply translation कर देता है. NSLOOKUP simply translation कर देता है. So I'm going to stop the sharing of the slides for a moment. ये मैंने slides रोक दी हैं. Now I'm going to share the screen, so everyone can see this this window here. देख सकते हैं? Command window देख सकते हैं? Yes, yes, ठीक है. Okay, so NSLOOKUP. You can see what I am typing, folks. Yes, yes, thank you. Okay, so NSLOOKUP. Let's say I say www or maybe venus.lums.edu.pk. This is a server which is hosted on LUMS network, venus.lums.edu.pk. So what it will do is that it will give you the name and the corresponding IP address. You can see the corresponding IP address here. Okay. So ये उससे पहले जो ये server और ये address आ रहा है, ये basically this is simply the addresses of the server who has made this translation for me. ठीक है, ये मैंने translation यहाँ पे नहीं की है, ये मेरे पास से पैकेट्स निकल के गए थे, DNS की रिक्वेस्ट गई थी और एक DNS सर्वर यहाँ लम्स के पास होस्ट हुआ है जिसका IP एड्रेस है 1099.017. वो कैसे पता है? वो मेरी मशीन को कैसे पता है? वो मेरी मशीन को ऐसे पता है क्योंकि मेरी मशीन की एक नेटवर्क कॉन्फ़िगरेशन है जिसके अंदर एक IP एड्रेस होता है, जिसके अंदर एक गेटवे होती है, and we'll talk about the gateway in the next chapter or the chapter after that. IP routing के chapter में हम पढ़ेंगे gateway के बारे में. So if you open up the network configuration of your machine, Windows की है या Mac है या Linux है, so the network configuration will have your IP address, your server IP address, एक subnet mask भी होता है, and then it will also have the address of the DNS server. And the reason that you have those DNS server is कि आपने किसी से जाके पूछना है भाई ट्रांसलेशन कर दो www.cnn.com, तो आपको पता होना चाहिए कि किससे पूछना है ट्रांसलेशन के लिए. Okay, so this is great. So venus.lums.edu.pk gets translated into this IP address. So let's try one more. NSLOOKUP www.usc.edu, University of Southern California, usc.edu. So देखते हैं क्या जवाब आता है. So ये देखें कितने सारे जवाब आते हैं. ये देखें इतने सारे जवाब आ गए. So एक ये IP एड्रेस आया, एक ये IP एड्रेस आया, एक ये IP एड्रेस आया. So ये सारे आपके पास IP एड्रेस आ गए. इनमें से किसी से भी राब्ता कर लें, इनमें से किसी के साथ भी कनेक्शन डाल दें. So basically what they have done is they have replicated their content onto these servers. और कोई ट्राई करते हैं. www.mit.edu एक आपके पास ये आ जाएगा. So MIT ने कोई रेप्लिकेशन तो उन्होंने की हुई है, ये अकामाई का नजर आ रहा है, लेकिन एक ही जगह के ऊपर शायद रेप्लिकेशन की हुई है. So MIT ने has done outsourcing to Akamai, लेकिन उन्होंने Akamai को ये नहीं कहा कि जाके 20,000 लोकेशन के ऊपर आप इसको रेप्लिकेट करें. उन्होंने कहा कि बस ये आप अपने पास रखें, एक ही जगह पे रखें, कोई मसला नहीं. ठीक है, and Akamai will handle the traffic to that website. So I'm going to stop this here now and go back to the slides. Go back to the slides. So CDN हो गया. Now we go to DNS. Okay. Now the job of the DNS, as we said, is the translation of these easily rememberable names, cnn.com, lums.edu.pk, into the corresponding IP addresses. The reason that we need that translation is because the packets which travel from source to destination, these packets include the IP address, and based on that IP address, the routers in between, they forward the packet all the way from source to destination. Remember, हमने क्या कहा था कि पैकेट्स के अंदर जो है आपका आईपी डेस्टिनेशन आईपी एड्रेस लिखा हुआ है, सोर्स आईपी एड्रेस भी लिखा हुआ है, लेकिन डेस्टिनेशन आईपी एड्रेस लिखा हुआ है. So that destination IP address, the router which receives the packet will open up the packet, extract that destination IP address, mash that destination IP address into a table that it has locally stored. हमें नहीं पता कि वो टेबल कैसे बना है, लेकिन वो will find out in some lectures. Okay, so उसके साथ मैच करेगा और फिर उसको कहीं पे भेज देगा. आउटपुट इंटरफेस नंबर 61 पे, आउटपुट इंटरफेस नंबर 61 पे, क्योंकि टेबल ने उसको ये बताया. ठीक है, और होपफुली टेबल ने उसको सही बताया, बिकॉज 61 पे भेजेगा. नाउ द पैकेट इज गोइंग क्लोजर टू द डेस्टिनेशन. Okay, now so what are the host names and addresses? So host name and addresses. So address तो ये IP address होगा. We have talked about it that it's a 32-bit number, and each of these octets ये 8 bits हैं. ये जो मैं सर्कल कर रहा हूँ ये 8 bits हैं. There are 4 into 8 bits, so it's almost always, it's mostly written in this notation which is called the dotted decimal notation. ठीक है. So since there are 8 bits here, you can go all the way from 0 to 255. So this is a number which is used by the internet protocol, and other protocols as well. Conforms to the network structure. It tells you where a machine is located. So it is important that I point that out here. When we say where a machine is located is indicated by the IP address, it means that all the IP addresses starting with 203.108, they will be found in PTCL's network. ये सब PTCL network में 15.something.something 15.something.something या पहला octet 15 होगा. all of those machines they belong to IBM or HP, one of these. Okay, 18.something belongs to MIT. Okay, so these organizations, they have gotten these set of IP addresses. Okay. So what you normally do is you buy a block of IP addresses. So लम्स वाले क्या करेंगे, PTCL को जाके कहेंगे एक ब्लॉक ऑफ IP एड्रेस हमें दे दें. सो PTCL वाले अपने बड़े ब्लॉक में से एक छोटा ब्लॉक जो है वो लम्स को दे देंगे. तो कहेंगे एवरीथिंग व्हिच स्टार्ट्स विद 203.108.32, उसके बाद 8 बिट्स जो हैं आपकी फारिग हैं, जो मर्जी उसमें यूज करें. ऑल ऑफ दोस 256 एड्रेसेस आर योर्स. So we'll talk about the blocks of IP addresses later on, in the not the next chapter, the one after that. Okay, and then we have, once we know that we have IP addresses, we also have host names such as www.usc.edu or venus.lums.edu.pk. They tell us who is this machine. Okay, so where is this machine and who is this machine? IP addresses are hierarchically distributed. Everything starting from 15.something is hosted at HP or IBM. Everything starting with 18.something is hosted at MIT, belongs to MIT. Okay. Similarly, everything starting with 203.108 belongs to PTCL network. फिर उसमें वो लोगों को बांट सकता है. So लम्स को कुछ बांट देगा और किसी बैंक को कुछ बांट देगा, जो भी उसके कस्टमर हैं. So these IP addresses will be hierarchically distributed. So the domain name system, the DNS is how we translate from this guy usc.edu to the corresponding IP address. So it's a directory service for hosts on the internet. And when it's a directory service, तो आप कह सकते हैं कि यार एक फाइल के अंदर रख लें. ठीक है, एक फाइल के अंदर रख लें, आप नाम लिख लें इधर और साथ आगे उसका IP एड्रेस रख लें. बहुत ज्यादा अगर तकलीफ है तो एक डेटाबेस के अंदर रख लें. एक कॉलम के अंदर आप जो है वो नेम्स डाल दें, दूसरे कॉलम के अंदर IP एड्रेसेस डाल दें, and you can just look up that SQL सर्वर में डाल दें या पोस्टग्रेस में डाल दें, किसी भी टाइप के जो डेटाबेस सर्वर में ये डाल दें सब कुछ, और वहां से आपको खट आंसर मिलता जाएगा. वेल द आंसर इज यस. या एक फाइल में डाल दें, वहां से भी आंसर मिलता जाएगा. पुराने जमाने में यही होता था कि आप एक फाइल में ही रखते थे, लेकिन स्केल का इशू आ गया. जब इंटरनेट बड़ा हुआ तो स्केल का इशू आ गया. So why do we actually bother? The reason that we bothered for this translation is because of the convenience. I don't want to remember this guy. Nobody wants to remember this guy. Everyone wants to remember this guy. Not just that, if you have a server venus.lums.edu.pk, you just need to remember that. बैक एंड के ऊपर उसका आईपी एड्रेस अगर चेंज हो जाता है फॉर सम रीजन, ठीक है, तो वो जो ब्लॉक लम्स के पास अवेलेबल था, वो थोड़े टाइम के लिए अवेलेबल था, वो चला गया और एक नया ब्लॉक आ गया, तो आईपी एड्रेस गॉट चेंज. आईपी एड्रेसेस डू गेट चेंज, नॉट वेरी ऑफ्टन, बट आईपी एड्रेसेस डू गेट चेंज. So that means you can also do the what we call indirection, level of indirection, which means that you decouple the names from the addresses, which means there are many uses just beyond just naming a specific host. And early days में क्या होता था? Early days में mappings would be stored, जैसे हमने पहले guess किया था कि in a file, उस file का नाम होता था hosts.txt. Every computer on the internet, every single computer on the internet will get a copy of this hosts.txt file. ठीक है, और ये इस डायरेक्टरी के अंदर पड़ी होती थी etc/hosts के अंदर. This was maintained by Stanford Research Institute, and new version जो है वो थोड़ी देर के बाद जब कोई होस्ट ऐड होता था तो वो फाइल को अपडेट करते थे और कॉपी कर देते, और using a protocol which is similar to HTTP but different, obviously. It's called file transfer protocol. Using file transfer protocol, HTTP did not exist in those days. So using file transfer protocol, आप वो SRI के सर्वर से जो है वो फाइल मंगवा लेते थे, अपने पास सेव कर लेते थे, and this file will have translation for every single machine in the world. Every single machine in the world. There were not too many. Okay. So then what happened? As the internet grew, this system broke down. Obviously. Okay? They could not handle the load. There were conflicts in selecting the names. हर बंदे ने कहा कि मैंने जो है वो sports.com जो है वो मुझे चाहिए, crickinfo.com मुझे चाहिए, shopping.com मुझे चाहिए. Everyone would say that. So hosts, they had inaccurate copies. The result was that they had inaccurate copies of hosts.txt, which means that translation was a question mark. So the DNS system was invented to fix this problem. ये जो प्रॉब्लम थी इसको फिक्स करने के लिए DNS सिस्टम इन्वेंट किया था. किसने इन्वेंट किया था? 4 students at UC Berkeley with the following goals. The goals were that it is scalable, global level के ऊपर हो, which means many names, many updates. Single database will not be able to handle that. Distributed database ही करनी पड़ेगी. Many names हो, many users creating the names. I don't want a central entity. उसको जाके मैं बताऊं कि venus.lums.edu.pk का IP एड्रेस ये चेंज करो. नहीं, I only want, मैं सिर्फ लम्स वाले को बता दूंगा और ये लम्स वाला जो है वो खुद ही अपडेट कर देगा अपने पास. We don't want a central entity. So administration जो है वो भी distributed करनी चाहिए इसके अंदर. And many users will be looking up names. DNS requests, they are generated all the time. हर दफा मुझे ट्रांसलेशन करनी पड़ती है. I request the DNS server to do that translation for me. So that means that there will be humongous load on the DNS system. So ऐसा system बनाना है जो ये इतना जबरदस्त scalable हो in all respects, and it should be highly available. Because if the DNS is not available, then you are dead. You cannot connect to the server because you don't know the IP address. Okay? So, so very interesting. We also want the DNS to be correct. There shouldn't be any naming conflicts. It should be unique and also be consistent. And the lookups have to be very, very fast because every web request that I am sending, it is preceded by a DNS request. अगर डीएनएस रिक्वेस्ट में ही टाइम सारा लग गया तो फिर तो आपका जो है पेज लोड का टाइम जो है वो वैसे ही बहुत ज्यादा हो जाएगा अगर सारा टाइम डीएनएस में है. आई वांट डीएनएस टू बी एक्सट्रीमली फास्ट, extremely fast. So how do we do that? How do we do that? The way that we do that is we partition the namespace. Namespace को partition कर देते हैं, ठीक है? And we distribute the administration of each partition. Namespace को भी partition कर देते हैं, यानी lums.edu.pk अलग हो गया और citibank.com.pk अलग हो गया and some other school.edu.pk वो बिल्कुल अलग हो गया, usc.edu अलग हो गया, amazon.com अलग हो गया. So you partition this namespace partition हो गई और उनकी administration भी जो है वो अलग हो गई. Everything which belongs to lums, suraj.lums.edu.pk, venus.lums.edu.pk, www.lums.edu.pk, zambil.lums.edu.pk, lms.lums.edu.pk, all of these are administered by one single entity. IST वाले वो उसको handle करते हैं, okay? And they have the autonomy to update their own machines. They have the autonomy to update the machines. Update the machines का मतलब ये है कि उनका IP एड्रेस अगर चेंज हो रहा है वो चेंज कर दें उसको. इनके पास autonomy होनी चाहिए, किसी एक सेंट्रल जो है वो एंटिटी से नहीं पूछना चाहिए, okay? And the reason that why you shouldn't ask a central entity is because of the scale. एक सेंट्रल एंटिटी अगर बिठा दी तो उसके पास तो ये सारी उम्र वो रिक्वेस्टें आती रहेंगी, वो कर ही नहीं सकेगा हैंडल उसको. And you also don't have to track everybody's update. लम्स ने कुछ आज अपडेट किया है, ये दुनिया को बताने की भी जरूरत नहीं, दुनिया को बताने की जरूरत नहीं, क्योंकि इतनी बड़ी दुनिया है, उनको किस किस को बताएंगे, ठीक है? जब उनको जरूरत होगी venus.lums.edu.pk को कांटेक्ट करने की, उस वक्त वो पूछ लें तो उनको जवाब नया जो भी फ्रेश जवाब होगा वो मिल जाएगा. लेकिन अगर मैंने वीनस का आईपी एड्रेस चेंज कर दिया, आई डोंट नीड टू टेल इट टू एवरीवन इन द ग्लोब. And you also distribute the name resolution for each partition. Name resolution का मतलब होता है कि translation from the domain name to IP address. This process is called name resolution. So हर partition, ये जो namespace की मैंने partition की थी, administration की मैंने partition की थी, इसके अंदर name resolution को distribute करते हैं. So how do we partition these things? The partitioning happens by using three hierarchies, three interrelated, intertwined hierarchies. एक तो हमने कहा कि hierarchy of namespace होगी, दूसरी hierarchy of administration होगी और तीसरी hierarchy of servers भी होगी, ठीक है? Central storage कहीं पे नहीं होगी, we will have a distributed storage. Okay? So for example, at the root we have something called root servers, and then everything finishing with edu is under that, everything finishing with .com is here, .gov, .mil for military, .org for organization, .net for network, .uk for the country UK, for .fr for the country France, .pk for the country Pakistan. Okay? And within edu you will have Berkeley, UCLA, all the other universities, and within Berkeley you can have the WCS department, you can have SIMS, koi other department, and then within EECS you have this instruction department. Okay? So you see that there is a hierarchy of the namespace. इस hierarchy के अंदर conflict आ ही नहीं सकता, कभी conflict नहीं आ सकता. So there will be a machine called instr.eecs.berkeley.edu. root नहीं लिखते वहां पे, root उस hierarchy के अंदर नहीं लिखते because everyone is tied to root. So देखें यहाँ पे कि आप ट्री के लीफ से उठ के जहां तक जाना चाहते हैं वहां तक चले जाएं, and then you are done. Okay? If you are talking about eecs.berkeley.edu, वो बस इधर से आ जाएंगे. There is no possibility of a name conflict. There is no possibility of a name conflict. So these are called top level domains. ये जो येलो सारे हो गए, ये edu, com, these are called top level domains, and the domains are subtrees, Berkeley, eecs.berkeley.edu. So, and the name will be leaf to the root path. So instr.eecs.berkeley.edu. So that's how we avoid the name collision automatically, trivially avoided. Each domain's responsibility. Okay? लम्स की रिस्पॉन्सिबिलिटी है कि वो venus.lums.edu.pk एक ही मशीन रखेगा, एक से ज्यादा मशीन नहीं रखेगा. So this is how you create a hierarchy of the namespace. You similarly create a hierarchy of administration. So hierarchy of administration क्या? Hierarchy of administration ऐसे होगी, ये पूरा जो है ये Berkeley का. So a zone corresponds to an administrative authority. Yes, say for example, all the top level domains are handled by this agency, by this organization, which is called ICANN, Internet Numbering Authority or something like that. And INA, these are two sister organizations or brother organizations, if you like. So they handle all the top level domains. उसके बाद हर एक की जिम्मेदारी है. LUMS वाला खुद अपना हैंडल करेगा. Berkeley वाला सेम ये अपना खुद हैंडल करेगा. EECS में भी within the Berkeley ये अपना खुद हैंडल करेगा. इट इज पॉसिबल दैट EECS वाला क्या है, हमने नहीं हैंडल करना, बर्कली आप ही हैंडल करें, तो दैट्स ओके, वो कर सकता है हैंडल. ठीक है. सो there will be a hierarchy of servers as well, and the hierarchy of servers, we are a little bit over time, so last slide, I'm going to finish now. So top of hierarchy you have the root servers, and the location is hardwired into the other servers. सबको रूट का पता होता है कि रूट कौन कौन से हैं, वर्ल्ड फेमस है. नेक्स्ट लेवल के ऊपर वी हैव TLDs और व्हाट वी कॉल टॉप लेवल डोमेन्स. ये .com, .edu, .org, .pk, .fr, .in, .sa सऊदी अरेबिया के लिए, and these are managed professionally. Okay. At the bottom level you have what we call authoritative DNS server. असल ट्रांसलेशन उनको पता होती है, असल ट्रांसलेशन. ऊपर वाले को कोई ट्रांसलेशन नहीं पता होती, लेकिन ऊपर वाले कहाँ इस्तेमाल होते हैं, ऊपर वाले आपको रास्ता सही बता देंगे. सो फॉर एग्जांपल, इफ आई वांट द ट्रांसलेशन फॉर shopping.amazon.com, तो रूट के पास जाऊंगा. रूट क्या यार मुझे नहीं पता, हाँ लेकिन ये amazon.com का ये सर्वर है, इससे जाके पूछो. फिर मैं जाऊंगा amazon.com वाले सर्वर से, वो मुझे कहेगा कि तुम जाके ये shopping.amazon.com ये इसकी ट्रांसलेशन है, दिस इज द translation. Okay. Similarly, install.eecs.berkeley.edu, तो टॉप लेवल रूट पे जाऊंगा, वो कहेगा नहीं edu से पूछो, edu से पूछूंगा, वो कहेगा नहीं berkeley से पूछो, berkeley से पूछेंगे तो वो कहेगा नहीं EECS से पूछो, तो EECS से पूछेंगे, वो ट्रांसलेशन दे देगा. इट विल बी अथॉरिटेटिव DNS सर्वर फॉर install.eecs.berkeley.edu, वो मुझे ट्रांसलेशन दे देगा. So as I promised, we will just finish here. If there are any questions, I'll be happy to answer now. Please raise your hand if you have a question. कोई question है तो please. So everything we have covered so far will be fair game for the test on Sunday. अगर कोई सवाल नहीं है, so I'm going to stop the share and give you one more opportunity to ask question. जी शोएब, आज शोएब का ही दिन है, शोएब सवाल पूछ रहे हैं.
ऐसा नहीं, ये सही टेस्ट क्या हाल है. So why don't we have a test window for this quiz?
Why don't we have
a test window for this quiz? मतलब जैसा 4 to 7 होता था उसके दरमियान आप कभी भी कर सकते थे. This time we have 4 to 4:35 बस.
हाँ, इसमें वो लीनियर एक्सेस हम दे रहे हैं, तो टेस्ट कर रहे हैं. दिस इज एन एक्सपेरिमेंट. अगर कामयाब हुआ तो ठीक है, नहीं हुआ तो कोई बात नहीं, नेक्स्ट वीक से फिर वापस आ जाएंगे, व्हिच मींस कि नेक्स्ट संडे को भी होगा एक और टेस्ट. लेकिन ये देखें 2 लेक्चर्स होते हैं, 2 लेक्चर्स के अंदर इतना ज्यादा कवर नहीं होता, तो वी जस्ट वांट टू मेक श्योर कि आप उसको जल्दी से रिवाइज कर लें, और फिर उसके बाद फिर अगर हम टेस्ट ना लें इतना फ्रीक्वेंटली तो होगा ये कि चीज़ें बहुत ज़्यादा पाइल अप हो जाएंगी, उनको मैनेज करना ज़्यादा मुश्किल होगा. सो आई जस्ट थॉट दैट फॉर एन ऑनलाइन सेटिंग इट इज़ मोर इम्पोर्टेंट कि आप जो है ये साथ साथ जो है वो चीज़ें पढ़ते चले जाएं, बिकॉज फाइनल एग्जाम भी नहीं है, कोई मिड टर्म भी नहीं है. I just thought that it is more useful to have this kind of smaller checkpoints rather than having a big kind of a thing. और किसी का कोई सवाल है? No more question? कोई क्वेश्चन नहीं? Great. Okay. Then I will just finish the session now. Thank you so much.